How exactly do you save a multi-billion-dollar coastal asset when the toxic debt compounds every 3 days? That is the exact mathematical nightmare tearing through the coral reefs of Florida and the Caribbean. We assume we can manage the ocean. We build massive culling programs and fund rapid response teams. We deploy thousands of divers to strip the reefs bare. We think we can extract our ecological mistakes by hand. But does human intervention actually repair a broken ecosystem, or does it just hide the bleeding? To understand the collapse, you have to investigate the initial spark. In 1985, a non-native predator appeared in the dark waters off the coast of Dania Beach, Florida. Biologists suspect it escaped from the local aquarium trade. It was a novelty pet that outgrew its glass box. Someone dumped an apex predator into an alien sea. 7 years later, Hurricane Andrew shattered the Florida coast and likely released more individuals directly into Biscayne Bay. Genetic evidence points to multiple human-caused introductions over several decades. Whatever the exact vector, human carelessness unleashed the perfect biological weapon. The lionfish drifted into the warm, rich currents of the Atlantic Ocean. It did not belong there. The reef did not recognize the threat. The invasion began. The lionfish operates with terrifying biological efficiency. A mature female spawns every 3 to 4 days. She releases 25,000 eggs in a single violent event. Over a single year, one fish unleashes up to 2 million eggs into the water column. Those eggs float in gelatinous rafts across hundreds of kilometers of open ocean. They drift for weeks on the Gulf Stream. They settle onto pristine new reefs. They consume absolutely everything. Once established, a single lionfish reduces the survival of native reef fish by a staggering 79%. The invaders swallow anything that fits inside their jaws. They have been documented consuming over 100 different species of Atlantic fish. They do not just hunt. They decimate the foundation of the food web. By 2010, the invader comprised nearly 40% of the total predator biomass on specific Caribbean reefs. On Bahamian reefs, populations of small juvenile fish collapsed by 80% within 5 short weeks of the invader arriving. The native ecosystem had no evolutionary defense against this specific hunting style. The lionfish blows jets of water at its prey, disorienting the smaller fish before inhaling them whole. The local Atlantic predators did not recognize the zebra-striped, spiny fish as food. The invader simply took over the ledger. This was the first documented case of a non-native marine fish establishing itself in the western North Atlantic. It was a completely unprecedented historical event. So if an invader prints its own currency and consumes the native market, how do you stop it? The common answer relies entirely on massive human bailouts. We treated the ecological crash like a manual labor problem. Florida launched extreme, state-sponsored eradication campaigns. From 2014 to 2023, the state hosted 187 different hunting tournaments. They extracted over 191,000 lionfish. Divers poured extreme physical effort into the deep reefs. They carried spears and containment tubes. They bled for this cause. The state removed over 1 million lionfish through the Lionfish Challenge program alone. The Reef Environmental Education Foundation hosted derbies in the Florida Keys, stripping 70,000 more from the saltwater. In 2024, a record-breaking 31,000 fish were killed by just 285 divers. The 2025 Florida Keys Lionfish Derby removed another 1,600 fish. The numbers sound huge. The physical effort is massive. The math still fails. Do these extreme extraction metrics actually solve the problem? Does manual culling reverse a permanent ecological crash? I want to know your exact read on this situation. If you were managing this coastline, would you keep funding the divers? Or would you let the reef collapse and reset itself? Drop your strategy in the comments. The federal government eventually admitted the hard truth. Dr. James Morris, a federal marine ecologist with NOAA, stated clearly that we cannot eradicate the species because we simply lack the technology. Human divers operate in shallow water during limited daylight hours. We cannot reach the deep mesophotic reefs. We cannot pull weeds from the bottom of the ocean fast enough to outpace 2 million eggs a year. We are bailing out a sinking ship with a teaspoon. So if manual extraction fails to balance the ledger, what happens to the rest of the ocean? We assumed the reefs faced total, irreversible bankruptcy. And then the invader simply started vanishing on its own. Around 2015, divers in the Florida Keys, the northern Gulf of Mexico, and the Bahamas noticed empty crevices. The ledges were clear. The visual counts dropped. The invaders were disappearing from the very reefs they had completely conquered. Researchers analyzed 11 years of rigorous survey data and confirmed the trend. The invasive populations increased exponentially until 2015, leveled off, and then steadily decreased through the end of the survey period. But what actually caused the crash? In August 2017, a coastal resource manager named Alex Fogg spotted something strange in the water. The lionfish carried open, ulcerative sores across their scales. A massive skin disease ripped through the northern Gulf of Mexico. Following the outbreak, the density of the invader plummeted by 75% on natural reefs. It dropped by up to 79% on high-density artificial structures. Up to 40% of the population showed active, rotting ulcers at the peak of the plague. The disease slaughtered the invaders. But does a random plague actually fix an ecosystem, or just delay the inevitable? Experts warned the disease was likely cyclical, not a permanent end to the invasion. The surviving fish would inevitably develop resistance. The population would rebound. A disease provides a temporary market dip, not a structural repair. So what happens when you investigate the specific artificial reefs where the lionfish never returned? The ocean deployed its own apex debt collector. On February 1, 2015, a researcher named Jim Hart lowered a camera into the water off Little Cayman. He captured something entirely unprecedented. A native Caribbean grouper opened its jaws and consumed a live lionfish. It was the first documented natural predation of this species in the Atlantic Ocean. But the real architect of this biological correction is much larger and much more violent. Enter the Goliath grouper. Imagine a prehistoric fish weighing up to 800 pounds. It haunts the rusted shipwrecks and artificial reefs of the Florida coast. Human greed nearly drove this massive predator to total extinction in the 1990s. We hunted them relentlessly for sport and meat. We recognized the massive damage and protected the species from harvest in 1990. We allowed the shattered population to slowly recover over 3 decades. Today, there is growing evidence that these enormous native fish consume and control the invasive predator on those same artificial structures. The mechanics of the hunt are brutally simple. A normal predator completely avoids the 18 highly venomous spines running down the invader's back. The Goliath grouper ignores them. The giant opens its cavernous mouth and inhales the water, the pressure, and the prey in one violent motion. No chewing, no hesitation. Just suction. The sheer physical mass of the native predator renders the venomous defense completely irrelevant. The spines fold harmlessly against the thick, calloused walls of the grouper's throat. The ocean engineered a perfect countermeasure. A species we saved from total extinction is now returning the favor by liquidating our worst ecological mistake. If witnessing a near-extinct native giant rise up to defend its territory from an unstoppable invader blows your mind, hit the like button right now. The native giant started clearing the wrecks. It looks like the perfect market correction. But if you analyze the peer-reviewed data, you uncover a deeply uncomfortable complication. Are the native predators actually hunting the lionfish, or are we corrupting their ancient instincts? A massive 2014 study examined the exact statistical relationship between native groupers and the invasive predators. The researchers found absolutely no negative correlation between the two populations across multiple reef sites. The presence of large groupers did not automatically equal fewer lionfish. The popular narrative collapsed under strict scientific scrutiny. The relationship between the two species is highly complex and fiercely site-specific. The groupers were not hunting them naturally across the entire ocean. So why were divers seeing groupers eat them on specific wrecks? We trained them to beg. For years, human divers speared the invaders and fed the bleeding carcasses directly to nearby sharks and groupers. A 2014 study published in the Journal of Experimental Marine Biology suggested this practice might teach naive native predators to recognize the invader as food. But critics fiercely oppose this method. Feeding speared fish conditions the native predators to associate human divers with an easy meal. They are not learning to hunt a dangerous venomous fish. They are learning to wait for a free handout. Sharks and massive groupers now aggressively follow divers across the reef structure. They exhibit a bizarre, unnatural behavior called pointing. The giant native predators hover near a deep crevice where an invader is hiding. They stare at the target like hunting dogs. They wait for the human to pull the trigger, kill the fish, and hand them the meat. Dependency is not predation. A handout does not fix a broken market. The Dutch Caribbean Nature Alliance issued strict, urgent warnings against this feeding practice. Feeding predators completely alters their natural diet and corrupts their hunting behavior. We are manufacturing beggars instead of restoring wild apex hunters. The best practice is to extract the invader from the water entirely and leave the predators alone. We corrupted the natural biological correction by injecting ourselves into the middle of it. We thought we were teaching the ocean. We were just breaking it in a new way. So where does that leave the actual balance of the Florida reefs today? We assumed the invasion was ending because the numbers dropped on our favorite local dive sites. We wanted a tidy, victorious narrative. But the federal data destroys that comfortable illusion. The federal authorities at NOAA maintain that the invasive populations continue to grow. They state the numbers swelled dramatically over the past 15 years and continue to expand aggressively across the ocean. The disappearance is a localized illusion. We are only looking at the shallow, heavily trafficked reefs. The invaders simply abandoned the shallow diving depths. They moved into the deep water where humans cannot reach them. They pushed south all the way to Brazil. They successfully breached the massive freshwater barrier of the Amazon River plume. That is a natural obstacle that separated Caribbean fish from South Atlantic species for millennia. More than 350 individuals have now been tallied along thousands of kilometers of the Brazilian coastline. They even colonized the Mediterranean Sea. They thrive in total darkness. The ocean fights back. The invader adapts. The cycle grinds forward. A massive study out of the University of Miami looked at 2 decades of monitoring data across the Florida Reef Tract. The numbers dropped and stabilized in specific locations, but the average physical size of the surviving fish increased. The population thinned out, leaving behind larger, stronger, more dominant individuals. The environment is not defeating them. It is simply establishing a new, permanent carrying capacity. So if manual extraction is mathematically impossible, and native predators are begging for handouts, what is the actual lesson here? The ocean operates on a massive, unforgiving timeline. Human bailouts buy time, but they do not solve the underlying ecological debt. Nature does not care about our millions of dollars or our extreme physical effort. The only thing that matters is raw biological leverage. The recovery of the Goliath grouper proves that native apex assets are the only force capable of executing a true market correction. But we have to let them do it on their own terms without our interference. If we keep injecting our own flawed management into the system, we only delay the healing process. We have to protect the native hunters, rebuild the complex habitats, and step back from the ledger entirely. Question for you. If human intervention is creating dependency instead of solving the crisis, should we stop culling the reefs entirely and let nature sort out the violence? Let me know your thoughts in the comments. Because right now, the ocean is forcing a brutal restructuring, and we are still trying to control the outcome. The invaders are not vanishing. They are simply integrating into the terrifying, violent machinery of a new ecosystem. They are becoming part of the permanent architecture. If you appreciate knowing the brutal truth about how an ecosystem actually repairs itself, you understand exactly why we document these stories. The real story is always much darker and much more fascinating than the comfortable lies we tell ourselves. If this changed how you see invasive species or what a healthy landscape actually looks like, let me know in the comments. And subscribe because there are more of these comeback stories than you would ever guess. Im Edmund Hale. Thanks for watching.